Hello everyone, I'm offering you a unique opportunity to test your school knowledge. It doesn't matter how well you did in school, whether good or bad, write your answer to the simple question in the comments below. You will be surprised by the result. So the question is as follows. Alright, so we have two symmetrical shelves. We have a shelf on the left side and we have the same shelf on the right side. Moreover, we have two balls. The first ball is at the top of a left shelf and mass is 1 kg. This is our ball on the left side, and we have absolutely the same ball, so the same mass. So here we have absolutely the same mass 1 kg, but this ball is 2 times bigger than ball on the left side, and we need to determine which ball falls off first if they start moving simultaneously. So the first ball roll down the shelf first, or the second ball roll down the shelf first. And right now, write your assumption, write your solution in the comments below, and then we will check our answer, so it will be really interesting. First ball or the second ball? We have the same mass on both sides, we have absolutely identical, absolutely symmetrical shelves on the left side and on the right side, and okay, right now, let's solve it and write your solution in the comments below. Alright, so before solving this question, I want to make few assumptions. So we know that we have absolutely identical shelves on the left side and on the right side. So we know that shelves are identical and each with length L equal to 0.5 meters. So we can get 1 meter, 2 meters, but for my calculation, for my solution, I'm going to get a 0.5 meter and the angle is 30 degrees. Because the shelves are identical and symmetrical, I choose, for example, 30 degrees. Here is our angle. So 30 degrees on the left side and 30 degrees on the right side. This is my first assumption. We can easily get it because we know that the shelves are identical and symmetrical from both sides. Second, my assumption, balls roll without slipping. So we are talking about pure rolling. Third assumption, air resistance is ignored. And the fourth assumption, shelf surface is smooth but provides enough friction for rolling. So according to my assumptions, these four assumptions, we can easily go to the next step. We can easily gather everything we know from the previous step. So we know the L, this is our length of a shelf. We have both absolutely the same shelves on the left side and on the right side. So L equal to 0.5 meters. Moreover, we know about theta. Theta is our angle. As I said before, we are talking about 30 degrees on the left side and on the right side. We know R, this is our radius, so this is our big radius right here, yeah, of a big ball. So we have our R, and we have right here we have small r. But if you're talking about comparing both balls, right here, this radius is 2 times bigger than the small ball. Okay, and the fourth thing we know about mass. So this ball, the mass of this ball is 1 kg, and we have absolutely the same mass on the in the second case. So we have 1 kg, and moreover, we need to find the time to roll down the shelf. So how fast this first ball roll down the shelf right from here, and the second ball, how fast the second ball roll down the shelf. So right now, let's split this question into two parts. Firstly, let's solve this shelf on the left side, and secondly, let's solve this shelf on the this on the right side. Firstly, this on the left side. So let's do it. Alright, so here is our first case. As I said before, we are talking about the left shelf. We know this angle 30 degrees. We know right here the mass is 1 kg. We know the radius. We know angle. We know the length of a shelf. So the first step, we need to find acceleration. Okay, acceleration down the incline. Okay, and here is our formula. A, this is our acceleration, equal to g. This is our acceleration due to the gravity, equal to 9.8 meters per second square. So we need to multiply it by sine theta. We know everything from here, so we can easily find real quick our acceleration. So a equal to g equal to 9.8, or you can easily get 10, doesn't matter right here if you want to solve this question quickly. So we have 9.8 in my case, and so times sine 30 degrees. So this is our angle right here. So we have 30 degrees. From here, sine 30, this is our table case, this is our 1/2. So a equal to 9.8, sine 30 equal to 1/2. So we can easily write it as a fraction, and we can easily get our answer from here. This is our 4.9 meter per second square. So this is our acceleration of a ball on the left side. So we have a 4.9 meter per second square. This is our acceleration. But don't forget about that we need to find the time to fall. And how can we find the time the ball roll down the shelf? So here's our formula right here. You can easily see it. So t, this is our time, equal to, we have square root of 2l all over a, and we know everything. So let's continue, for example, right here on the left side, equal to square root of 2l. So we have 2 times l equal to 0.5. Yeah, 0.5. We don't need to convert because we have meters right here. Yeah. And we're going to divide it, all of this, by a equal to 4.9. We're not talking about acceleration due to gravity. We're talking about acceleration that that can get this ball on the left side. So equal to, we can easily find approximately answer according to your calculator. We have the square root of 0.204, and this is approximately equal to 0.452. We're talking about seconds, so this is half a second, yeah, something like that. We're talking about half a second, so this is our time that the first ball rolled down the shelf. So we can easily write it. For example, let's do it right here. So the time equal to 0.452. So the first ball rolled down the shelf in like 0.452 seconds. Okay, so I really hope you get it. So we solved the question according to a first ball. But one really important moment, because the time to fall depends on acceleration. Yeah, we have right here acceleration. Right here, yeah, we have acceleration. So the time to fall depends on acceleration down the incline. So we need to know the angle as well. But one really important moment, which is this acceleration will be the same for both balls, since mass and angle are identical. Okay, so the larger radius affect the moment of inertia, but we're talking about pure rolling, and pure rolling ensures acceleration is independent of size. So for this, we really need only a length of our shelf. We need to angle, and moreover, we don't need the mass right here. We don't need it, and we don't need the radius, so it doesn't matter in our case. So we can easily find the time according to length and according to the angle. Right now, let's go to the second part. So we have the second shelf. So let's do this. All right, so the second shelf, as I said before, we have the same length, 0.5, and we have the theta, 30 degrees right here, and we know the math, and moreover, we know the radius. So this radius is 2 times bigger than the small ball on the left side. We don't have it, but I just sketch it real quick. Right now, let's do the same thing. Let's try to solve this left part. Solve this part with the right shell. First of all, let's find acceleration real quick. Acceleration down the incline equal to a times g times sine theta. And as I said before, we don't need right here any length. We don't need a math. We don't need a radius. We really need only this angle. So the angle is absolutely the same. So we have 9.8 times sine 30 degrees, but 30 degrees, so sine 30 equal to 1/2. So we can easily multiply 9.8 by 1/2 equal to 4.9 meters per second square, and this is absolutely the same value as we had before. So acceleration for both balls will be the same. Okay, so we're talking about 4.9 on the left side and on the right side. And right now, let's find our time, because we need to find the time to roll down the shelf. Time the second ball roll down the shelf. So t equal to, we have square root of 2l over a equal to, we have square root of 2 times l equal to 0.5, so 0.5 all over a equal to 4.49. This is our acceleration, and we don't need to convert because we have absolutely great measures. We're talking about kg, we're talking about the kilo, yeah, we're talking about meters, so everything is great. Okay, and equal to square root of 0.204, and right here absolutely the same value as we had before, so 0.452. So the time the second ball rolled down the shelf equal to 0.452 seconds. And right now, the really interesting moment, now really important moment, because as I said before, our left balls, right here we had 1 kg, acceleration was absolutely the same on both sides. So we have absolutely the same acceleration. We have a absolutely the same on both sides. But on the left side, our t equal to, so approximately equal to 0.452. So we solved it a little bit. We solved it before, but on the right side, so we have t approximately equal to 0.452. So we have absolutely the same time. So it's not like that the first ball rolled down the shelf. Firstly, this one. Secondly, we have absolutely the same time. So a correct answer to this question. So both balls fall off the shelf simultaneously in approximately 0.452 seconds. But let's make a real quick analysis, because a really important note. So the larger radius increases moment of inertia, but pure rolling ensures the same acceleration. So radius, we don't care about radius in this case. We have absolutely the same mass, and moreover, we don't need math in our question, so we don't need this 1 kg. We can easily cancel it, so we don't need a mass in our question. We don't need a radius, yeah. And when we get this assumption that I did before, so few assumptions. So the first assumption that the ball rolls without slipping, we are not talking about air resistance, so air resistance is ignored. And the third one, shelf surface is smooth but provides enough friction for rolling. According to these three assumptions, we can easily get rid of this radius. We can easily get rid of this mass. We can easily cancel all of this. We really need this angle, and we really need the length of a shelf. So according to these two values, we can find our answer. So the time is absolutely the same for both sides, and time depends only on the shelf length. Yeah, time only depends on the shelf length and acceleration, which are the same for both balls. For the first ball, we had like 4.9 meters per second square, and we have absolutely the same acceleration for the right ball. So we have 4.9 meter per second square. So the larger radius does not affect time in the absence of air resistance or slipping. So if we're ignoring air resistance, so we don't need this, and we don't need this radius. If air resistance were considered, the larger ball might face more drag, but this is ignored for simplicity. Okay, so we ignore it in the beginning. We ignored air resistance, but if air resistance were considered, the larger ball might face more drag, but this is ignored for simplicity. So our answer, this is not like this ball follow the shelf first, or this one follow the shelf first. We are talking about equality sign. We're talking about equal sign. So in our case, we're talking about equal sign. So both balls fall off the shelf simultaneously in approximately 0.452 seconds. So I really hope your answer is the same as mine. Write your thoughts, write your assumption in the comments below. Let's discuss a little bit about this question. So I think, like, this is my feeling, that a lot of students might be thinking that bigger ball, this one, I think I give for this one, let's give, for example, 80%. So I think that a lot of students might be thinking, okay, bigger ball, fall off the shelf, roll down the shelf firstly. This one maybe 20% because it's like a smaller ball. But in our question, we have the same balls. To be honest, we have the same balls with the same mass. So we have 1 kg. This is the first mass. We have the second mass, and absolutely the same thing. Even like length of the shelf are absolutely the same. So we have absolutely the same. Even we have absolutely the same angle. So absolutely the same thing. And a lot of students might be thinking that this ball fall off the shelf or roll down the shelf first, like 80%. So this is my prediction. Yeah, this one, maybe a lot of students might be thinking that something like tricky moment. Maybe this one will roll down the cliff first. But in our case, in our question, we have equal signs. So our conclusion for both balls fall off the shelves simultaneously in approximately 0.452. And as I said before, time to fall depends on acceleration down the incline, which is the same for both balls. We have absolutely the same acceleration on the left side and on the right side. If you're talking about, if we have, for example, on the right side, if we have, for example, like not 4.9, but for example, we have a equal to 5.0. So acceleration right here is bigger. Yeah, and we need to plug in it into our formula. Our formula looks like that. So as I said before, we have t equal to square root of 2l over a, and right now we need to plug in it. Yeah, we need to get a bigger time or a smaller time. Yeah, we need to consider it, because this is a very important moment. And if this acceleration is different from this one, so we need to plug in it, and we need to see maybe time will not be the same. This is really important moment, because 5.0 meter per second square and this acceleration different, so it means t is going to be different. Yeah, and one of this ball will roll down the cliff firstly. Okay, this is really important moment. So as I said before, the time to fall depends on acceleration down the incline, which is the same for both balls. Since mass and angle are identical, yeah, we have absolutely identical thing from both sides, absolutely identical length, absolutely identical angle. Right here 30 degrees, and right here 30 degrees. So the larger radius affects moment of inertia, but pure rolling ensures acceleration is independent of size. Yeah, so we're talking about inertia, but in our case we're talking about, basically we ignored air resistance. Shelf surface is smooth but provides enough friction for rolling, and balls rolls without slipping. After all this assumption, two formulas, and here's our answer. So both balls fall off the shelf simultaneously in approximately 0.452 seconds. So we are talking about the first ball and the second ball gonna be here simultaneously. Yeah, we have equal signs, so simultaneously. This is my explanation to this question. I really hope you understand it. I really hope you learned something new. You can write your thoughts, write your assumption in the comments below. Let's discuss a little bit about this question, because a lot of students might be thinking this one full of roll down the shelf first, maybe this one full roll down the shelf first, and it turns into a big argument. A lot of students arguing with each other about this question. And of course, if you have something to my solution, write the solution, write your notes, write your tricks, write your prompts in the comments below. Let's discuss a little bit about it. It's going to be interesting if you write something new in the comments below. Yeah, so thank you for your time. Take care of yourself. Have a great day. See you in the next videos.